So here the question is, what matrix 2 by 2 we would multiply by vector xy so we can project it onto the x-axis so that we would get a 0y component. So if this is our vector v, which is xy, what would I multiply it by? So I would get the projection of it on the x-axis, which is this. So I need to get x0. Okay, so just knowing, without having to remember any prior definitions, if we just know the basic concept of matrix multiplication, we know that this is going to be a 2 by 2 vector, 2 by 2 matrix, and the fact that this is a 2 by 1, that means the multiplication matrix has to come first, which is our unknown, and we need to operate with that on the vector xy, and that should get us x0. And the reason I line them up like this is because if this is a 2 by 2 and this is a 2 by 1, to be able to multiply, because these have to be the same, the number of columns on the first matrix has to equal to the number of rows on the second matrix, and I know my end result has to be a 2 by 1, which is this. So I know that the rotation matrix or the projection matrix has to come first. And now knowing that matrix multiplication goes row by column, I know that the x needs to survive, so that tells me that this needs to be a 1, and the 0, and I'm not supposed to get any y, so this is supposed to be 0, so it would wipe the y away, because when I multiply these two I would get x plus 0y, which is x, and I know that the y has to go away and the x has to go away on the second multiplication, so this needs to be a 0 0, because this will get me 0x plus 0y, and therefore the answer would be the matrix 1 0 0 0. So the first answer to the problem, so projection matrix 1 has to be 1 0 0 0. Okay, and now the second part of the question, what matrix P2 projects onto the y-axis to produce 0y? So now I'm supposed to get out of this guy or this guy, the y component of the vector, and this would be 0y. Okay, with a very similar analysis like the first one, I'm supposed to get 0y. Okay, with very similar reasoning, I need these two to go away, so these have to be 0 0. Oops, let me write this in gold.
First one, P1, would just be
so this has to be 0 0. Yes, that is correct. The first one is 1 0 0 0. Okay, and now I need my y to survive, so the x have to be 0 and y has to be 1, so I would get y on the second component. So my P2 would be 0 0 0 1. And the third question, it says, if you multiply 5 7 by P1, then multiply by P2, you get if you multiply, okay, so let's do that. So 5 7 by P1, so P1 was 1 0 0 0, and we're supposed to multiply 5 7. Oops. 5 7. I know this has to come next for the matrix multiplication to work out, and here of course what would I get? Well, if you apply that, what this does is it gets you the x component of the vector, so you're supposed to get 5 0, because that's the x component, and you do. You get 5 plus 0 times 7 is 5 and 0, so you get this. And then if I go ahead and multiply by p2, so then I would get 5 0 and multiply it by 0 0 0 1. Oops, this has to go on the right hand side. Now this is supposed to get me the y component of the vector, but this vector 5 0 does not have any y component, so I'm supposed to get 0 0, which I do if you do the multiplication. That does it for this question.